In this example, we have the vector pair v equals negative 5i plus 3j, and w equals negative 6i minus 2j. And we are going to find v dot w, or the dot product of v and w, as well as the angle measure between v and w. We will round this angle, and I will do so in degrees, to 2 decimal places. In this case, we have our two vectors in unit vector decomposition mode. So we're using I and j instead of component form for these vectors. If it makes you more comfortable, remember you can always change v and w into component form if you'd like. However, in this case, the operations are not going to change much, so I will progress through with what we have. First, the dot product. The dot product of v and w is what you get when you multiply the associated components. So I'll multiply the first components of v and w. The first component of v is negative 5. And the second component, or the first component of w, is negative 6. I'm going to add that to the second components multiplied, which would be 3 for v and negative 2 for w. If you do multiply all these through, negative 5 times negative 6, that will give you positive 30. Then we have plus 5 times negative 2. We have 30 minus 6 overall. Or 30 minus 6, that is 24. And that's our dot product. Not really much going on there. However, we can use the dot product in order to calculate the angle measure in between if we consider the geometric interpretation of the dot product. That being v dot w equals the magnitude of v times the magnitude of w times cosine of theta, where theta is the angle measure between v and w. This formula for the dot product is not one that we would actually use to calculate the dot product directly, but is one that we can use the dot product in order to solve for theta, the angle between the two vectors. Before we could do that, though, we still have a couple missing pieces. We need both the magnitude of v and the magnitude of w. So let's quickly solve those. The magnitude of v, we can find that because that is basically just the Pythagorean theorem with the first and second components of v. So that'd be negative 5 squared plus 3 squared underneath a square root. Well, that gives us the square root of 25 plus 9. Or just the square root of 34, which I will keep it as it is. Same thing for w. First and second components of w squared and added, so that would be negative 6 quantity squared, as well as negative 2 squared. Negative 6 squared is 36. 2 squared, or negative 2 squared, is positive 4, which gives us the square root of 40. If you would prefer to write this, say, as 2 times the square root of 10, you can also simplify it to that, but I'll just keep my magnitudes as they are. A little bit easier to work with them right now. But using those, we can now calculate theta by rearranging this geometric interpretation of the dot product formula. To get theta by itself, that would be arc cosine of that dot product, v and w, divided by the magnitudes of v and w multiplied. So that means we have arc cosine of the dot product, which we found earlier was 24, divided by my two magnitudes squared, so square root of 34 times the square root of 40, which I will use a calculator to approximate this. If I bring up a calculator, I'm going to do this in degree mode, so do make sure that you are in that same mode to match here. We have arc cosine of 24 divided by these two values multiplied, so square root of 34 times the square root of 40. Do make sure you're careful with things like parentheses to make sure that The square root of 40 is indeed in the denominator there. That gives us an angle measure of about 49 point to 2 decimal places 40. We now have the dot product and the angle measure between. Quick note, the second that we solved for our dot product here and it came out to be a positive 24, I already knew that the angle between the two vectors would therefore end up being an acute angle measure, which it did here. 49.4 is acute as it is less than 90. I know that because in this formula, the only thing that could possibly influence the inside to be negative is the dot product, as we always indicate the magnitudes as positive. Therefore, since the dot product is either positive or negative, you can always figure out what kind of angle measure we expect. Since it's positive, I expect one between 0 and pi over 2, or in degrees, between 0 and 90.